Okay, so let's go to, oops. So today we're looking at the product rule and the quotient rule for differentiation. So what I'm going to do here very quickly, in around 10 minutes, I'm going to give you the rules. I'm going to show you the proof of the product rule. And then I'm going to do one example, and then I'm going to have you guys work on some problems on your own. Okay, that's kind of the goal. So we're kind of done with the warm-up. We're kind of getting right here, and then we're going to quickly get into this activity. So if you've watched the video, which most of you raised your hand, I tried to make an argument for why the product rule isn't what you'd think it would be. You'd think that if I wanted to do the derivative of f of x times g of x, you'd think it'd be the derivative of f of x times the derivative of g of x, wouldn't you? Unfortunately, that is not the case. In fact, does anybody know what the product rule is?
It's f of x times g of x.
It's f of x times
Derivative of g of x.
Derivative of g of x.
Plus g of x times the derivative.
Okay, nice. You need to know this. You need to memorize this. Okay, this is the product rule. This is the problem. What I'd like to do right now is I'm actually going to show you a proof. Now, do me a favor. Do not write down anything I'm getting ready to show you. I want you to just watch. Okay? I'm going to come back to this slide, so if you're trying to write this down, that's okay. I'm going to leave it up there. But I'm going to show you a real quick presentation here. Okay, so I'm going to do a proof of the product rule. I need my clicker here. All right, so I'm trying to find the derivative of f of x times g of x. Okay, so by our formal definition, that's by section 2.1, we've got to take the limit as delta x goes to 0 of the f of x function plus delta x times, so I'm doing the product here, which is what this is, but then I got to minus the product of the two functions without the additional delta x divided by delta x. That's just our formal definition of derivative. Now the next step, first of all, notice right now that this is exactly the same thing as this. Okay? I'm going to put two additional terms here in blue. Now what I'd first like you to notice is if you take this negative and plus this positive, what do you get? 0. In other words, what I'm telling you is by putting this blue term here and this blue term here, I have not changed this expression at all. It's still the same value. Okay? And you might think, how would I know that? This is the hardest step. You'll see as we work things out. Okay, so now what I'm going to do is the following. I'm going to break this limit into two pieces. This piece and then this piece. So all I've done now is I've taken this one big limit and I've broken it into two pieces using the sum rule for limits. This is going back to chapter 1. Okay, so what do these two guys have in common? Do you see that g of x plus delta x? Do you see that's how it's in both terms? So guess what I can do to that? I can factor that out using the distributive property. You guys remember factoring? Okay, can you see what these two guys have in common? What do they have in common? Okay, good. So guess what I can do with the f of x? I can factor that out. Okay, I'm going to go to the next slide. The next slide is going to be the exact same step that we just finished on. This is no different than the previous step. Now I'm going to do one more thing. I'm going to take, this is the sum of two limits. What I'm going to do now is I'm going to break up this limit into two parts. So I'm going to use a product rule of limits like so. So I'm going to break those into two individual limits. And I'm going to do the same thing over here. I'm going to break those into two limits. So I've done the sum rule for limits. I've done the product rule of limits. So this is all going back to chapter 1. Now I've got some important questions for you. Now I've got it set up the way I want. If delta x is going to 0, what's this going to become? Just g of x. And that's exactly right. That's going to be g of x. The most important question I have for you. Does anybody recognize what this is? It is the derivative of f of x. So that makes it g of x times f prime of x. Well, here I'm taking delta x going to 0. There's no delta x, so guess what that is? That's just f of x. And finally, does anybody recognize what this is? It's the derivative of g of x. Guess what we have? That is our So now, let me just tell you, by the way, QED just means that's the end of the proof. I am never going to ask you to do this proof on an assessment. I am just showing you this product rule, and let me get out of this here real quick. This product rule that I just wrote up here did not just magically fall out of the sky. People figured it out. This is the product rule. Okay? You guys know what the quotient rule is?
Yes.
Okay, so let's see here. I'm going to do the quotient rule, so that's going to be, let's call it f of x divided by g of x. What is the quotient rule?
G of x times the derivative of f of x minus f of x times the derivative of g of x
Over G of X.
over g of x squared.
Okay, if you guys don't mind, I'm going to write it like this on the bottom, just for you'll see why in just a second. You guys remember, you'd agree that g of x squared is the same thing as g of x times g of x, right? Okay, so I'm telling you right now, there are two things in this lesson that you need to memorize, and they are right here. However, before I move on to my example, have you guys ever heard of Please Excuse My Dear Aunt Sally? You guys remember Please Excuse My Dear Aunt Sally? We teach that to kids in middle school to help them remember the order of operations, correct? Yeah, middle school, I think. Yeah, isn't that when you guys learned that?
I definitely learned it in like fourth grade.
Fourth grade. Wow, that's you must be really advanced. I didn't do it till I was in middle school. But anyways, so Please Excuse My Dear Aunt Sally. That's called a mnemonic device. It helps us remember things. Would you guys like to see a couple of mnemonic devices to kind of help remember these? Because on the test, you don't get to use your notes, right? So I'm going to give these to you. You do not have to use them. And these are not the rules. These just help you remember the rules. Let's do it in green. By the way, we could say that that's kind of the first function and that's the second function, right? So for the product rule, here's the mnemonic device, if you will. Here's how I do it. You may already hear some of you saying this. Now let me explain what it means. Remember, this is 1, this is 2. 1 times, guess what D stands for? Derivative. So 1d2, 1 times the derivative of 2, plus 2d1, 2 times the derivative of 1. Would you guys say that with me? 1d2 plus 2d1. Let's do it a bit faster. Ready? 1d2 plus 2d1. Now you might, look, when I was sitting where you're sitting, when a teacher would say something like this, I'd be like, oh, come on. Guys, I just turned 49 years old. Guess what I do on almost every problem where I have to do the product rule? In my head, guess what I do? 1d2 plus 2d1. So I don't screw it up. Particularly when I'm doing it in front of people like you. I don't want to screw it up, and then you guys are like, whoa, Mr. Ryan, you don't even know what you're doing. Okay. So let's do the same thing down here. This one's a little bit different. This one here, this is I'm going to call it the high function, and this one down here, we could think of that as the low function, right? So here's the quotient rule. The quotient rule. So it's going to be low d high minus high d low over low low. Okay? Can you guys say that with me? Ready? Low d high minus high d low over low low. If you want to say low squared, I'm fine with that. Let's do it one more time a little bit faster. Ready? Low d high minus high d low over low low. Those are your product rules and quotient rules. Now, guys, I'm giving them to you in a very abstract way right now. Now we're going to move on to our activity where I'm going to actually have you using these rules to get derivatives. Okay? So remember, chapter 2 is only about finding derivatives pretty much. So that's what we're going to do today. We're going to use the product rule and the quotient rule to find derivatives. Okay. Let's look at number 1 together. In fact, if you feel confident, you can just go ahead and start working ahead. Oops. Okay, I want to work on number one. I just want to make sure we get a feel for what's going on here. And I also want to give you a little bit of instruction on this. So which rule do we need on number one? This is clearly the product rule, right? We've got a parenthesis times another parenthesis product. When you do number two, guess what rule you're going to need? You're going to need the quotient rule. But let's just do one together here, okay? Now, what I've tried to do with this activity is, obviously we want to practice the product and the quotient rule, but I'm actually going to be having you review some of the stuff from section 2 as well. So here's what I do when I do a problem like this, is I literally write this. I literally will write on my paper. Now that isn't the product rule, but it just helps me make sure I get things straight in my head. 1d2 plus 2d1, that's that shortcut rule, if you will, for me to remember what it is. Now, whenever you do a derivative, we're going to call it y prime, or you can call it dy over dx. I'm going to use y prime. So what does 1 mean? 1 means you leave the function or the expression exactly as it is. So notice I did not change 1 at all. It's simply just x squared minus 4x minus 6. What does d2 stand for? Derivative of 2, right? So now I'm going to use my derivative rules to find this derivative. Now, you may already know those, but I'm going to go through them real quick just to make sure we remember. Let's start with the first part. What is the derivative of x to the third using the power rule? Okay, 3x squared, I hear some of you say with confidence. The 3 goes to the front, and then you subtract 1 from the exponent. What is the derivative of negative 5x squared? Well, that'd be negative 5 times 2x, or negative 10x, correct? And then the last one, what is the derivative of negative 3x? Negative 3. Now I'm done, right? No, Simon shaking his head. That's right. We're only halfway there. So far, we've done the 1d2 part. Now we got to do the 2d1. So 2 means I leave the second function completely alone. I just leave it as it is. So there's the 2 part. Now I got to do the derivative of 1. Let's do those rules again. What is the derivative of x squared? 2x. The derivative of negative 4x? Negative 4. The derivative of negative 6? 0. And guys, here's what I want you to do. Today, I'd like you to kind of focus more on the calculus than the algebra. In my directions, it says I'd like you to get this in factor form. I'm just telling you right now, this doesn't really factor. The only thing you can factor out of this is you can factor a 2 out of this and an x out of that. But do me a favor, just stop there. This is the answer. That's the derivative. Okay? Can you handle that? Now, so here's some more. Now notice here, 3 and 4. Don't do both 3 and 4. Pick one and do one. Okay? Then when you get down to some of these here, like 5, notice the question's different. It's not just saying find the derivative. It's saying find the equation of the tangent line. So make sure you're reading your directions. I'm going to go ahead and let you get started. Feel free to work with someone close to you. I'm going to have to adjust my time a little bit. I'll put a timer up here to let you kind of know how long I want you to work.